This is workbook page 59. So we're going to go through solving this inequality and graphing the solution set. So first we're treating this particular inequality. It's just a one-step inequality, like a one-step equation. Our goal is to get x alone on one side of the inequality symbol. So I have x minus 3 is less than or equal to 2. So hopefully by now we know that we're doing the inverse or the opposite operation. So since this is minus 3, I'm going to add 3 to both sides of the inequality symbol. Negative 3 plus 3 leaves me with 0. So I have x is less than or equal to 2 plus 3 is 5. And then I can go ahead and graph that. I'm graphing all numbers that are less than or equal to 5. So because I have the less than or equal to symbol, I am going to fill this in, close, that's a closed circle because 5 is a solution. And I'm going to shade down. It will include all of these numbers. So I know if you guys are using a pencil in your workbook, it's going to be pretty hard for you to just draw one line. So you really want to go back and forth and really kind of like color that in, shade that in. Oops, that's getting messy, but color that in, shade that in, make it really obvious that your arrow is going in that direction. And then it's always a good idea, of course, to check your answer. Oh, sorry. So I'm going to check that any of these answers meet my inequality. So I'm just going to choose any solution. I'm saying all of these numbers that are highlighted in purple basically are solutions. So let's start with 0. Instead of writing 0 into my inequality, instead of writing x into my inequality, I'm going to write 0. So 0 minus 3, is that less than or equal to 2? Well, 0 minus 3 is negative 3, and yes, negative 3 is less than or equal to 2. And I could have tried any one of these numbers, right? I could have tried 4. So again, instead of writing x, I'm going to write 4. 4 minus 3, is that less than or equal to 2? Well, 4 minus 3 is 1. 1 is less than or equal to 2. So I've gone ahead and checked to make sure that yes, in fact, I did graph in the correct direction and that my solution is correct. So when we are adding and subtracting, when we have inequalities that involve adding and subtracting, they're going to follow this same pattern. So the bottom of workbook page 59 looks like this. Let me get a different color here. I'm not loving this color. Maybe I'll try this. See how that looks. All right. So problems 2 to 5 is asking us to apply this operation to show both sides of the original inequality, write the new inequality, and state whether or not the statement is true or false. So right now we have 3.5 is greater than 1. So right now, yes, this is a true inequality. 3.5 is greater than 1. But what happens when we subtract a half from each number? So that means that we are going to be subtracting a half from this side and subtracting a half from this side. What happens? Well, 3.5 minus a half is 3. Is 3 greater than or equal to, greater than, and 1 minus a half is a half. Is 3 greater than a half also true? Yes, it is. So this is what we're doing. We're doing this operation to every single one of these inequalities. So for number 3, we're adding 0. So what do you think? Obviously, nothing's going to change. Negative 4 and 2/10 is less than 10.5. That currently is true. If we add 0, we're going to get negative 4 and 2/10. Is that still less than or equal to 10.5? Yes, of course. Now, what about when we have a negative number, when we're adding a negative number? Right now we have -1 is greater than or equal to -9. That is true. Don't get confused. -1 is greater than -9. So what if we add 2 and 1/10? So I'm going to add -2 and 1/10 to -1 and also to -9, because whatever we do to one side of the inequality, we have to do to the other. We can't just do something to one side. So when I add -2 and 1/10 to -1, I get -3 and 1/10. And when I add -2 and 1/10 to -9, I get -11 and 1/10. Is -3 and 1/10 greater than or equal to -11 and 1/10? Yes, it is. Nothing has changed. And our last one, 25, is greater than 13. That is correct. Let me just erase this little dot. And when I subtract 4, 25 minus 4 is 21. Is that greater than subtracting 4 from 13? 13 minus 4 is 9, and yes, 21 is greater than 9. So no matter how I added or subtracted, right? All of these had different, we were adding or subtracting something different. In number 2, we were subtracting a half. Number 3, we were adding nothing. Number 4, we were adding a negative. Number 5, we were subtracting. And no matter what we did, if we had a positive number, a fraction, a negative number, when we were adding or subtracting, our inequality stayed the same, right? All of these were true. Our direction of our inequalities did not change from where we started. And again, all of the inequalities were true to start, and they were also true to finish. Nothing changed. I'm going to have you guys practice number 6 and number 7. And let's talk about multiplying and dividing in this video. So let's see if multiplying and dividing follows the same patterns that adding and subtracting did. So we're going to do the same thing. We're going to apply the operation to both sides of the original equality and state whether the new inequality is true or false. So right now I have -2 is less than 10. Right now, that is true. So if I multiply both by a half, -2 times a half is -1. Is -1 less than 10 times a half is 5. Is -1 less than 5? Yes, it is. So it was true to start, and it's true to finish. Right now, number 9, we have 25 is greater than 10. We're going to divide by 5. 25 divided by 5 is 5. And 10 divided by 5 is 2. Is 5 greater than 2? Yes, it is. And of course, 25 was greater than 10. So it was true to start, it's true to finish. Number 10, we have 3.5 is greater than 1. Of course, that is true. 3.5 is greater than 1. But now we are going to multiply 3.5 by -2. So positive times a negative is going to be negative. And 1 times -2 is -2. Is -7 greater than -2? No, don't get confused. No, it is not. This is a false inequality. -7, if we have our number line, right? 0's here, 1 is here, -1 is here, right? All of these numbers are bigger than these numbers, they're smaller. So -7 is over here. -2 is here. -2 is greater than -7. Not, -7 is not greater than 2. All right, let's take a look at number 11. -4 is less than or equal to 16. That is true. Now let's divide by -4. -4 divided by 4, a negative divided by a negative is positive. So -4 divided by -4 is 1. Is 1 less than or equal to, dividing 16 by -4, a negative divided by a positive is negative. -4 is -1, is 1 less than or equal to -4? No, it is not. And number 12, we have -1 is greater than -9. What happens if we divide by -1/2? So -1 divided by -1/2 is 2. Is 2 greater than or equal to -9 divided by -1/2, which is 18? Is 2 greater than 18? Hopefully that's pretty obvious. No, it is not. Oh, I meant to make that in pink like my other falses. No, -2 is not greater than 18. So what are we noticing here? I'm noticing that when we are multiplying or dividing by a positive number, our inequality stayed true, right? We started with less than, we ended with less than, it was still true. We had greater than, we divided by a positive number, we had greater than, it was still true. But then when we were multiplying or dividing by a negative number, now things are changing, right? So I multiplied by these negative numbers or divided by these negative numbers, and with my inequalities facing in the same direction, it was false, right? It started off true, and now it went to false. Okay. So what happens? How can we make it so that we can solve these inequalities and get a true? We want true, oh, that's an I. We want true statements, right? How can we do that? Well, if we flipped each of these inequality symbols, then it would be true, right? So let's take a look at an example of that. Let me find one that's a negative. All right, so number 14. Right now we have -3 is greater than or equal to 12. So this is a one-step equation or inequality. So we're solving it just like we would solve a one-step equation. We want to get t alone. So here we are going to divide by -3, divide by -3. -3 divided by -3 is 1, so we get 1t, and 12 divided by -3 is -4. So what we're going to do right now, I'm gonna keep the inequality symbol the same and see if this makes sense. We're just gonna say t is greater than 4, -4. So let's test this out and see if this works. Let's see if these are the answers to this inequality. So I'm saying numbers like 0 are an answer, 1, 2, 3, -2. I'm saying all of these are answers. So the way that I can check that is into my original equation. Instead of, oh, yellow is probably not a good color. I don't know why I did that. I guess I'll go to this one. Instead of writing t, I'm going to write any one of these answers that I'm picking. So -3, let's pick one of these numbers on the number line. Let's pick 0 because multiplying by 0 is easy. So instead of writing t, I'm going to write 0. So -3 times t, -3 times 0. Is that greater than 12? Well, -3 times 0 is 0. Is 0 greater than 12? No, it's not. Well, let's try another one just to be sure. What about -2? -3 times negative 2, is that greater than 12? 3 times 2 is 6. A negative times a negative is positive. Is 6 greater than 12? No, it's not. So even though I think I did my work correctly, this number line is not giving me correct answers, right? So let's take a look at that. Let's try that again. What can we change? What if I flipped that inequality symbol? I already erased it, but as you can see in the original equation, the inequality symbol was greater than. What if I flipped that to be a less than? And now I'm saying t is less than negative 4. And I'm saying, wait a minute, maybe my number line should go this way. Well, let's take a look. And instead of writing negative 3, I'm going to write one of these answers into my equation. Right now, I can only see negative 5 on my number line, but let's try it out. Negative 3 times negative 5, is that greater than 12? Well, 3 times 5 is 15. A negative times a negative is positive. Is 15 greater than 12? Yes, it is. So by flipping that inequality symbol, I was able to now come up with a true inequality, right? And I could check any other numbers, right? Even though my number line on this page is pretty short, I can imagine, right? Negative 10 is over here, still on my number line. I could pick negative 10 to check. Negative 3 times, instead of writing t, I'm writing negative 10. Is that greater than 12? Well, negative 3 times negative 10, 3 times 10 is 30. Negative times a negative is positive. 30 is greater than 12. So that does, in fact, work.